Okay, this is homework 2.5, question number 1. We want to find the domain, and the function is to find the domain of a function. We set the denominator equal to 0. We solve this equation, and we call this a bad point. That means we can pick any number for input from negative infinity to positive infinity except 2. And the best way to write your domain in interval notation is draw a line, put 0, 2 is positive, so put it on the right-hand side and make an open circle. This is your bad point. You can pick anything before, anything after. Then you have to write an interval notation and start from left with negative infinity all the way to this point 2, but you don't want it, so you put parentheses. Again, pick everything up after 2. Again, put parentheses to exclude 2 to infinity. For infinity and negative infinity, we put parentheses. Question number 2. And we also want to find the domain for such a function. So you're going to set the denominator equal to 0 and solve this equation. This is a trinomial equation where the coefficient of x to the power 2 is not 1. So for these problems, this is one of the methods that you can solve. This problem, by multiplying 10 and 3, you get 30. And then you change 10 to 1. And then you factor this. You want two numbers to multiply to give you negative 30 and add to get 1. Such numbers are 5 and 6. 5 and 6 are different by 1 point. So we want to have a positive 1. So we put positive 6 and negative 5. Because 6 times negative 5 is negative 30. And 6 plus minus 5, which is 6 minus 5, is 1. So we want to get 1. And we want to get negative 30. So these are the factors. We break x to the power 2 as x and x. We put positive 6 and negative 5 inside the parentheses. We divide them by this number 10. 6 and 10 are reduced. You have to remember to divide by this coefficient and reduce. So you get x is equal to, you get x plus, both are divisible by 2. You get 3 over 5. These are both divisible by 5. You get 1 over 2. You don't want to have any fractions. So you move this 2 here and you move the 5 here after you reduce. So you get 5x plus 3, 2x minus 1. So that's what the factors for the denominator is. And remember, we are supposed to set the denominator equal to 0. And then we set each factor equal to 0. You add 1 to both sides. Then you divide by 2. So 1/2 is a bad point. You subtract 3 from both sides. You divide by 5. And negative 3/5 is a bad point. So what do we do next? We have 2 bad points. We are going to draw a line. This is infinity, negative infinity. This is 0. Negative number goes to the left. Just randomly go and pick a point on the left for negative. Positive 1/2 goes to the right. Randomly pick a number for positive 1/2. These are your bad points. You can pick anything from negative infinity to positive infinity, except those 2 points for x. These are the numbers you cannot pick for input. So How do we write our domain in interval notation? Start from left, go to the bad point. Bad points get parentheses to get included. Again, from this bad point to the next. And then from this bad point to infinity. So do you see your bad points? They all get parentheses. And then you put a U. These are parentheses. So that's how you find the domain. Question number 3. Determine the vertical asymptote. So vertical asymptote is a line, imaginary line. If you use a graphing calculator, for instance, you don't see that line, but it's a line that you draw to say that we are not going to have a graph at that bad point. So again, vertical asymptote is helping us to, it reminds us that we excluded certain points in our domain. So it just reminds us again what those bad points are. So to find a vertical asymptote, or the domain, we set the denominator equal to 0. Except when we are finding the vertical asymptote, we are supposed to reduce our function first before we set the denominator equal to 0. But for the domain, we always set the denominator equal to 0. So anyways, x minus 6 is equal to 0. We add 6. This is how we find the domain as well. When we get to this point, remember this is our bad point. We call that bad point a vertical asymptote equation. And that's how you have to enter it in ALEX. And all it is, you're saying that when I graph, since if this is 0, positive 6 is here, do you remember you said we are going to put a hole, not to put a graph here, not to pick it for our input? You just put a line in ALEX to say that, you know, watch out, don't put any, you're not going to have any graph here at 6 because we can't pick 6. That's what the vertical asymptote does. And to find it, you just set the denominator equal to 0 and solve for x. Next question, we want to find the vertical asymptote again. We have f of t equals to t plus 5, 2t squared plus 5t minus 3 minus 3. And for this one, again, to find the vertical asymptotes, we are going to set the denominator equal to 0. Then we multiply 2 by 3 because this is a trinomial that the coefficient of t squared is not 1. So we turn it into a 1 by multiplying 2 by 3. We get 6. We change 3 to 6. And then we change 2 to 1. And then we say 2 numbers to multiply to give us negative 6. Such numbers are 1 and 6, right? 1 times 6 is 6. But we want to get a positive 5. So this has to be positive and this has to be negative. Because again, negative 1 times 6 is negative 6, right? And if I add them, I do get positive 5 because this is 6 take away 1, which is positive 5. So these are the factors. You open up the 2 parentheses, you break t squared to t and t. You put negative 1 and positive 6. And then don't forget to divide by 2. You're not done yet. You reduce, you get t plus 3. 6 and 2 are reduced. You get 3 and 1. Since you have a denominator here, move it here. You get 2t minus 1, t plus 3. Then you set it equal to 0. And you solve each parentheses. Subtract 3, you get t is negative 3. Or you can do the trick here and Opposite of positive 3 is negative 3, and opposite of that is positive 1 over that 2. Or just go ahead, subtract 1, divide by 2, you get t is minus 1/2 is a vertical asymptote, and t is minus 3 is another vertical asymptote. So you put those vertical asymptotes to remind yourself that you're not going to have a graph there. So we are going to do the next problem. Question number 5, it says the graph of f of x equals to negative x to the power 2 plus 8, 2x to the power 2 minus 3 will behave like which function for large values of x? Pretty much is asking you find horizontal asymptotes. So when it says find the behavior of the graph for large values of x, that means when x goes to negative infinity and positive infinity, what is the behavior of the graph, which is asking you to find your horizontal asymptote. So watch the lecture on this. So you look at the leading term from the top, which is that. The leading term from the bottom is that. Since these exponents are the same, your answer is going to be the coefficient, which is minus 1 over 2. And that is the equation you're looking for. That's all you had to do. Question number 6, it says the graph of, it gives you a function, which is negative 5x to the power 4 minus 3x plus 1 divided by x to the power 5 plus x to the power 2 minus 5 will behave like which function for large values of x? So again, it says when we have absolute value of x, when x is massive or super small, that is, as x goes to infinity or negative infinity, what happens to this graph? You look at the leading term. The leading term is a term with the highest exponent on the top, negative 5x to the power 4, and x to the power 5 on the bottom. Since 4 is smaller than 5, then you say y is equal to 0. That is your horizontal asymptote. So remember from the lecture, we said if these two numbers are the same, this is your horizontal asymptote, the coefficients. And if the top number is smaller than the bottom number, or the bottom is bigger than the top, you get 0. Question number 7. It says identify the horizontal asymptote, and if the graph of the function has any horizontal asymptote, determine the point, if any, where the graph crosses the horizontal asymptotes. So again, we want to find the horizontal asymptote for this function. And sometimes horizontal asymptote gets touched or crossed by the graph. Normally we say asymptote means do not touch, and the graph goes in parallel with the asymptotes. The only asymptote that could be crossed or touched by the graph is the horizontal asymptote, and there's a test for that. So first I'm going to find my horizontal asymptote, the top exponent. This is the one term, and that is the highest exponent. The degree of 5 is 0. The degree of this is 0. The degree of this 2, 0. This is 2. 0 is less than 2. Therefore, y is equal to 0 is our horizontal asymptote. And then it says, is the horizontal asymptote going to get touched or crossed by the graph? To test that, you set the function equal to the horizontal asymptote. And then you solve. To solve this equation, since you have one term here and one term here, you can multiply this bottom by the top of the other side and 1 by the top of the other side. 5 times 1, 0 times that. But when you multiply 0 by anything, you get 0. 5 times 1 is 5. 5 equal to 0 doesn't make sense. It's a false statement. So in this case, horizontal asymptote will not be touched or crossed by the graph. Next question. Question 8. We have r of x is equal to negative 3x to the power 2 plus 2x minus 1, x to the power 2 plus 5. We want to find the horizontal asymptote and then find out if it's going to be touched or crossed. That's the leading term from the top, and that's the leading term from the bottom. Why they're leading term? Because they have the highest exponent. The degree of this polynomial is 2, because this one has a degree of 1, this has a degree of 0. So the degree of the top polynomial is 2. That makes that the leading term, not because it's first, and the bottom, that is the leading term. Since these two numbers are the same, the horizontal asymptote is going to be just the coefficient of these two, which is negative 3. That is our horizontal asymptote. It's negative 3 over 1, which is negative 3. Okay? So, now that we have found the horizontal asymptote, we are going to find out if it's going to be crossed or touched. And to do that, we are going to set the function equal to the horizontal asymptote. To solve this equation, we multiply 1 by the top of left-hand side, and we multiply the bottom of the left-hand side by the top of right-hand side, okay? 1 times negative 3x to the power 2 plus 2x minus 1. We multiply negative 3 by the bottom of the left-hand side. So this way we don't have any denominators. Then you distribute, you get minus 3x to the power 2. Negative 3 times 5 is negative 15. When you distribute 1, nothing happens. You just get negative 3x to the power 2 plus 2x minus 1. Then I want to move all the terms like negative 3x to the power 2 to the other side, add it to both sides. I get 2x minus 1 is equal to negative 15. This is a linear equation. Our goal is to isolate x. We get rid of the number that is being added or subtracted. So we add 1 to both sides. Negative 15 plus 1, we end up subtracting. We get negative 14. Divide by 2. We get x is negative 7. So yes, horizontal asymptote will be touched or crossed at negative 7. So one of the point of the graph is negative 7 when y is negative 3. So when we have a horizontal asymptote here, negative 1, negative 2, negative 3, that's our horizontal asymptote. But one of the point on the graph is going to be at here, negative 7 and negative 3. That's all it says. So the next question says, write an equation of the slant or nonlinear asymptote, which is called the oblique asymptote. So if we don't have a horizontal asymptote, we will have an oblique asymptote, and the way to find it is called f of x. So every time they tell you to find either when you're looking for asymptotes, if it's not a vertical asymptote, right now, I want to know if this is going to have a horizontal asymptote. This is the leading term from the top because it has the highest exponent 2. The leading term from the bottom is x to the power 1. And since 2 is bigger than 1, we don't have a horizontal asymptote, no horizontal asymptote. Instead, we have something which is called oblique or slant asymptote. And to find it, we are going to divide. So how do we do divide these two? We can do, what is it called? We can do synthetic division. We write the coefficient of the top function, top polynomial, 1, -4, 5. And since we are dividing by x minus 8, we are going to write it as positive 8. 1 times 8 is 8. You add these two, you get 4. You end up subtracting. 8 take away 4 is 4. 4 times 8 is 32. 5 and 32 is 37. So the equation of the slant asymptote is, do you remember this is x to the power 2? This is going to be 1 less. This is 4, so you put a positive. That is the equation. So you say the equation is x plus 4. So later on, when you want to graph this function, this is how your obligate asymptote looks like. 1, 2, 3, 4. Slope is 1. So you will have this imaginary line on a graphing calculator, but for Alex, probably you have to graph it. And then this helps you with graphing this function. So your graph is going to go in parallel with this oblique asymptote. Question number 10. It says for the graph of y is equal to f of x, where f of x is given to us, we have to find x-intercept, vertical asymptote, y-intercept, horizontal or slant asymptotes, and so forth. So this is our function. F of x is x minus 3, x 3x minus 5, x plus 1, 3x plus 2. So what do we want to do? We want to find x-intercept. To find the x-intercept, what you do is you set the numerator equal to 0. For this type of functions, when you have one term, one fraction, then you set the denominator equal to 0. Numerator. Okay, so that's how you find your x-intercept, by setting this equal to 0. To solve this, you set x minus 3 equal to 0, 3x minus 5 equal to 0. You solve. The shortcut is you're going to say opposite of negative 3 is positive 3, opposite of negative 5 is positive 5, and divided by that coefficient. So these are your x-intercepts. When x is 3, y is 0. When x is 5 over 3, y is 0. So if you were to graph this function, your x-intercepts are going to be at 5 over 3. Let's say this is 5/3 and 3. So these are your x-intercept. Your graph is going to cross the x-axis or touch the x-axis somewhere here. Then let's find the y-intercept. To find the y-intercept, you're going to change all the x's to 0. So I call f of x y, and then I write my function. Only where I have x, I'm going to leave parentheses. Again, I have x plus 1, 3x plus 2. Do you see what I did? Every time there was an x, I put parentheses. Why? Because I want to find y-intercept, and for y-intercept, we are letting x equal to 0. We are going to put 0 for x. So what is 0 minus 3? 0 minus 3, 0 will be ignored. You get negative 3. What is 3 times 0 is 0. So you get 0 minus 5, ignore 0. So what you're left with is negative 3. Don't drop your parentheses, because the parentheses are indicating multiplication between the two. So don't drop them. 0 plus 1. Again, when you have 0, just cross it, unless you are multiplying by 0. But if you're adding, subtracting 0, just erase it. You get 1. 3 times 0 is 0. 0 plus 2, so ignore 0. You have 2. Don't drop the parentheses, because these parentheses are indicating multiplication. Negative times negative is positive. You get 15. 1 times 2 is 2. You get 15 over 2, which is about 7, which is 7.5. So that is your y-intercept. So we have y-intercept, we have x-intercept. Next, we are going to find a vertical asymptote. To find a vertical asymptote, we set the denominator equal to 0. Vertical asymptote, set your denominator equal to 0. So x plus 1, 3x plus 2 equal to 0. Again, you set x plus 1 equal to 0, solve the equation. You set 3x plus 2 equal to equation and solve the equation. Or you could do a shortcut. Opposite of positive 1 is negative 1. Opposite of positive 2 is negative 2. Don't forget about this 3 goes into the denominator. And then you say x equals to negative 1. And x is equal to negative 2/3. And you separate them. You have to say x is equal to, otherwise Alex counts it wrong. So x is negative 1 and x is negative 2/3 are your vertical asymptotes. We also want to find our horizontal asymptotes. So to find a horizontal asymptote, if we don't have a horizontal asymptote, then we have to find the oblique asymptote. But how do we find it? You have an x times 3x. That's how you find it. So I'm just going to write the equation. I have x minus 3, 3x minus 5, and x plus 1, and 3x plus 2. We multiply this x by 3x. We get 3x to the power 2. We multiply this x by 3x. And that also gives us 3x to the power 2, because we are only concerned with the leading term. By multiplying this x and 3x, this x and 3x, you get the leading term for the top and bottom. Since the exponents are the same, they're both 2's. This is a 2, and this is a 2. Then we say that horizontal asymptote is 3, the coefficients, 3 over 3, which is 1. So your horizontal asymptote is 1. The same thing for the next question. We want to find everything we did on the previous example. To find the x-intercept, set the numerator equal to 0. Subtract 8. Divide by negative 3. Negative over negative is positive, 8 over 3. This is your x-intercept. To find the y-intercept, change all the x's to 0. So I change that to 0 and change that x to 0. And I get, this is 0. 3 times 0 is 0. When you have 0 cross it, you just get 8. 0 squared is 0. Cross it, you get 9. So that's your y-intercept. Next, you're going to find your vertical asymptote. In this case, you set the denominator equal to 0. You have one x term, so add 9 to both sides. You square root both sides. The side that has a number, put a positive negative. You get x is positive. The square root of 9 is 3, and negative 3. Because the square root of 9 is 3, you get positive, negative. So write 2 equations. To find a horizontal asymptote, keep the leading term from the top. This is your leading term. This is your leading term, negative 3x. This is the leading term from the bottom. Compare. 1 is smaller than 2. That makes horizontal asymptote 0. And that's the end of it. For the last question, it says sports trainer has monthly cost of $68